Hey everyone, it's Mrs. Brimlow, and today we're going to look at functions and how we graph them and some of the ways we can represent them. So, a copy of these notes are linked in Canvas. You can also get a copy when you return and follow along with the video. So, we know that functions are made up of ordered pairs. They're a relation that each input has one output. But where did these come from? Well, we talked about a vending machine and how there's a computer component that uses a rule or function to get you your snack when you put in your money. So when we're talking about math, we're talking about an equation. And some of these equations should look familiar because we've actually been working with functions for over a month now, but we weren't calling them functions, we were calling them linear equations. So linear equations or linear functions are made up of a set of ordered pairs that work specifically for that function where each input gives you exactly one output. So if I put a number into an equation, I should only be getting another number out, only one. So let's say we're given a function in an ordered pair. How do we know if it's part of the function or not? How do we know if it's not just some random point off a graph? Well, that's where we're going to use our algebra to check. So for this first section, we're determining if each ordered pair is a solution, if it's one of the ordered pairs, part of that function. So all you have to do is substitute the x and y values into the equation to see if it works or if it's a true statement. If it is, then it is a group part of that ordered pairs. The ordered pair is part of the function. And if it's not, then it's just an ordered pair. So you'll notice some of these once again look familiar because they're written in slope-intercept form with slope and y-intercept. And so, starting with the first one, as a reminder, xy, so the linear equation or function rule for this is y equals 4x plus 2. If I substitute this ordered pair into the equation or function, is it part of it? So that's what we're going to check. So where I see y, I'm going to replace 10. And where I see x, I'm going to replace 2. And then I'm just going to see if this works. So I'm going to bring down 10. 4 times 2 is 8 plus 2. And that works. That means 210 is an ordered pair part of this function. And if you think about it, when I put 2 into this rule, the only thing I can get out of it is 10. It can't be 211, 212, 21. It's 210. That's the only one. So whenever you put 2 into this function rule, 10 is what you get out of it. Therefore, this ordered pair is part of the function. Okay. So we're going to do one more. Now, this is actually a function as well. It's just written in a different form. So when I go ahead and replace x and y, so this is 2 times 7 plus 5 equals to 5. So 14 plus 5 equals 5. That's not true. So that means the 0.75 doesn't work. Now, if I put 7 in to the equation, that would give me 14. When I add 5 to it as the output, it doesn't give me 5. So it doesn't work for this equation. If I had another number here that would work, such as -9, so if this 5 was a -9, that would be the correct output. 7 and -9 would work together. Also, if I had a 0 instead of x, 2 times 0 is 0, plus 5 gives me 5. That would work too. So these numbers can be used, they just can't be used together as an ordered pair. Okay, so you should try the rest on your own, and then once again, you can email me with questions or ask when you return. So with this in mind, we know how to graph these equations quick because we know slope and y-intercept or slope-intercept form. But this is really where it comes from. This is where those ordered pairs come from. It's not just because you go up 2 over 3, starting at, wherever your y-intercept is. It actually comes from how the rule works and how the input and the output work together for that specific rule. So for these problems, you're given a set of input values, you're given a function. So once again, you're going to put your input into the function, you're going to use the rule and get an output and then graph it to see what it looks like. So they give us 7, 4, and 0 for our domain or input values. So where I see x in this equation, which is adding 2 to it, that's the work I'm going to do, and I get an output of 9. So as an ordered pair, 7, 9 is part of this function. And the only number 7 can get for an output with it being an input is 9. So 4 plus 2 is 6. So this is 4, 6. And then 0 plus 2 is 2. So 0, 2. So we're just going to plot these points. Okay, we're not graphing it based on slope-intercept form. We're graphing it based on these points they gave us. So they gave us 7, 9, 4, 6, and 0, 2. And you'll notice that it's forming a straight line that's linear, and that makes sense. This is a linear equation or a linear function. We can see it starting at 2, and that's what we had for one of our values, but we can see that, and we can see how it's increasing, and it's got a positive slope. So this makes sense and is kind of tying it all together. So you want to make sure you use a straight edge, doesn't matter what it is. Draw a line through your ordered pairs. Some arrows at the end to show it keeps going, because technically it does, okay? So you're going to fill out the tables for the front and the back, or the front and the next page, and then you're going to graph them just like we did. If you have any questions, let me know, and I will chat with you soon.